right. Hello, welcome again. Here we go. Lesson 4-6, Regression and Median Fit Lines. Let's go to our learning objective. Right back here. And the important words. Let's see. We're calculating using technology the correlation coefficient between two quantitative variables and interpreting quantity as a measure of the strength of the linear association. And we're also writing with and without technology linear functions that provide a reasonable fit to data to estimate solutions and make predictions for real-world problems. Okay, so yeah, we're going to be doing both of these things. Let's see if we put it all together. Let's say our learning objective. We will calculate the correlation coefficient. And we kind of dipped a little bit into this yesterday. Okay, we will calculate the correlation coefficient. We'll able to and interpret this quantity. We will also use linear functions to estimate solutions and make predictions. Okay, let me scroll up. Go ahead and write that down. Okay. Here's our vocabulary. First one is the best fit line. The line that most closely approximates the data in a scatter plot. Okay, so just like we discussed yesterday, we have these coordinate planes and then we have these dots. Okay, a best fit line is a line that goes right through those dots. Okay, you should end up with about half of them above and half of them below. Okay. The next one, linear regression, an algorithm to find a precise line of fit for a set of data. Linear regression. So what that is, when we come up with linear regression, that's a way of coming up with the equation for that line. Okay? That equation lets us predict values. Our correlation coefficient. Our correlation coefficient values show how close the data points are to the line. So, how close those data points are to the line. There, in the top example, you know, they're okay. They're pretty close. But if I gave you an example like this, where we had all of our dots really close to the line, okay, that's super close. That's a much stronger relationship right there, okay? So again, just like yesterday, we talked a little bit about this. This would be considered a weak but positive correlation. And this is also a positive but strong correlation, okay? This would present a good argument, something that you could make a good prediction regarding. Residual, the difference between an observed y value and its predicted y value on a regression line, okay? So if I'm looking at, let's say that I have my coordinate plane, okay? This right here is going to be my line of best fit. So something that looks like this. And I end up with a point that's located, oh, I don't know, like right here. So when I'm examining that line, it's the difference between where I thought it would be. So probably right there, I thought it would be there, but actually it's much lower. That's our residual. This green line right here, that is the residual. Should probably do that in darker color. Residual. Okay, that's the distance from here to there. Okay. Median line fit. It's a type of best fit line that's calculated using the medians of the coordinate of the data points, okay? Because I guess there's multiple types of fit lines, and specifically there's a median fit line. We probably won't get that detailed. Okay. Our first example, real world example number 1, earnings. We have this table that shows Ariana's hourly earnings for the years 2009, 2015. We're going to use a graphing calculator to write an equation for the best fit line for this data. Find and interpret the correlation coefficient. And let X be the number of years since 2008. Okay? So I'm going to adjust my table here just a little bit. And I'm going to put in X. In 2009, how many years has it been since 2008? Well, if you said 2, that would be wrong. What's the right answer? If you said 1, outstanding. 1. Okay? So that means in 2010, how many years has it been since 2008? 2. Yes, you're getting better. And then 3. And then this one, we're just subtracting 8, from 12, and we end up with 4. Okay? So I'm going to do the same thing here. Just kind of add a little extra. And I'm looking at 5. 14 minus 8 is 6, and then 7. Okay? So I have my data. This is my X, and cost is going to be Y. Okay? So we use our graphing calculator. And we're going to enter our data. Now, if you have a graphing calculator at home, I strongly encourage that you check them out. So those of you that have them, awesome. That's great. If you're in the classroom doing this lesson, please follow along with your calculator. So how do we put a table into our calculator? Good. We go to Stat, and then we go to Edit. Okay? So now I'm going to select all my X values. Okay? So we had said 1 and 2 and 3 and 4 and 5, 6, and 7. Those were all the X values, the years since 2008. Okay, I go to the right, and I'm going to put in all my cost values. 10, 10.50, 11, 13, 15, 15.75. Enter. Okay, and 16.50. Okay. Now that I have that, how do I get an equation? If you said stat calc 4, good. And then you just go ahead and hit enter until you calculate. Okay? So ladies and gentlemen, our equation for best fit is, and we're going to round to the nearest hundredth, okay? We're going to round to the nearest hundredth. Okay, so I'm going to take it back to my notes, and where it says equation of best fit, I'm just going to write in y equals 1.21x plus 8.25. okay? Because I rounded to the nearest hundredth. Now my correlation coefficient. In order to get the calculator to give this, let's go ahead. We have to change that setting, right? And the bright side is that once you put that setting on, you don't have to redo it. That setting is actually located in mode, okay? And we want to go down till we get to stat diagnostics. So it's on the second screen, okay? Stat diagnostics. And see how currently it's off? See, I'm going to have it right here. As soon as this thing, okay, there we are. So it's the cursor's right there on off, and we want to set it to on. So I'm going to go to the right, and I'm going to select enter. Now, when I move away from there, notice how the word on is highlighted or selected, surrounded in black. So to get out of that screen, I hit second mode to quit. Okay. And now I go back into stat. I'm going to come up with my equation the exact same way I did. I don't have to re-enter my table. So I just hit stat, to the right, calc, and then 4 because it looks like linear regression. Hit enter about 5 times. And ladies and gentlemen, we have R is equal to 0.98. Okay? Remember yesterday in class we talked about our correlation coefficient? Okay? So if we're looking at our correlation coefficient, R was equal to 0.98. Remember, we have our little number line, right? 0 means no correlation, right? If it's close to 0, it's probably weak, okay? And if it's really close, the closer it gets to 1, then it's considered a strong correlation, okay? So 0.98, is it closer to 1 or 0? It's really close to 1. It's like 98 cents is really close to $1, right? 0.98. So we consider that strong and positive. Okay? This is a strong and positive correlation. Okay? So what that means is that there's a very strong relationship between the year and the cost. And so what we can do is we can feel pretty confident that if we plug in a value for something else, then we can definitely feel pretty confident in what our answer is going to be. So they said this last sentence here says, let X be the number of years since 2008. Yes, we got that. Did they ask for something that they want us to predict about? No, not yet, but we'll get to there, okay? So if they did tell us, hey, it's 2017, what would you plug in? In 2017, you should probably plug in 9 for X, right? X would be equal to 9. You plug that in, you get your answer, and you have a fairly certain that it's going to cost about that amount in 2017. All right. The graph and the meaning. So when I'm graphing this, let's see if I've got a graph here on this next slide. Nope. Okay. Let me go ahead and put up a graph here. Okay, it looks a little bit different than y'all's, but you get the idea, okay? So we have y is equal to 1.21x plus 8.25. Where do I start off at? The y-intercept, yes. And so I'm going to go ahead and I'm going to count up to about 8.25. That's 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. And I'm going to put a dot right there. Now 1.21. I don't like that. I'm going to make it a fraction, okay? Let's get out of here. Okay. And I'm going to just put in 1.2. It's going to be very approximate anyway. And I'm going to hit math, enter, enter. See if I can get a nice little fraction out of that. You going to give me a nice fraction? There we go, 6 over 5. Okay. So let's go over to our notes. So 1.25 is approximately 6 over 5, right? Which means that I could go up 6 and over 5, which I'm kind of running out of room. But I could definitely go down 6, right? I'm at 8.12, so I'm going to end up just right about here. And then I'm going to go to the left because that would normally be up and to the right. But instead, I'm going to take it in reverse. So I'm going to go down 6 and over 5. So I got like 1, 2, 3, 4, 5, right? So I'm going to go down 6 and then to the left by 5, right? And again, I could do that again. Okay. I could go down 6. That's about 1, 2. Let's see. 1, 2, 3, 4. So about down 6 and to the left by 5. Okay. So my line of best fit is going to end up something like this. Yes? You can graph it that way. And then we would also want to graph our little points. Our scatter points look like this. I've got 2009, so that's 110. So 1 all the way up to 10. You know what? I'm going to do this. Why not? Put a dot. Yay. Okay. And then I've got at 2, I've got 10.5. Oh, so my line goes off in the other direction, right? Okay. Let me go ahead and extend this line out. Okay. So I'll probably only be able to do a few because I'm kind of short here. So I've got, in 2 years, we're going to reach about 1050. So that's about right there, right? And then 2011, we got about, another 50 cents. So that's probably right there. So as you can tell, just with those 3 points, are we looking at a strong correlation or a weak one? It's really strong. It's practically on the line, right? So that's super strong. That's why it's like at 0.98. All right. So I think that's sufficient for the graph. Okay. If you have any questions, make sure that you ask me. Okay. Again, on your calculator, if you wanted to see how this would look, it looks like this. In order to put it into your calculator, you select, and you can take notes on this. You go to Stat, go to Calc, okay, and then you go to 4. In order to store it, you go down to Store Regression Equation right here. And then you're going to select vars to the right, 1, enter, okay, and then enter until you get to calculate. Notice you'll have Y1 right here, right? Y1 is already right there, so that's telling you where it's going to store it. And then you select enter. Okay, so you end up with your regression because we've already set that up in our mode. And now when we go to y equals, it's already typed in, yes? I'm going to go ahead, go up 1, and hit plot 1 so that all my little points will show. See how when I back away it's selected? And we go to graph. I'm going to zoom out a little. Zoom 3, enter. See that little wad of points right here? Those are our points. And the line going right through it, that's our line of best fit. Okay? That's what it would look like on your calculator. Oh, the meaning. That's really important. Let's go back to that. So, on our x-axis, we have the year. Okay. We have the year. Not helpful. All right. We have the years since 2008, right? And on the y-axis, we have our cost. Okay. And so what we're looking at is the meaning. Well, the meaning would be that as the years increase, you know what? I really almost think I want to be more specific because I have an exact slope. So I'm going to say, in general, for every year that passes, the cost increases by $1.21. And in 2008, the cost was $8.25. Okay? So you can see that's a lot more specific than just saying, as the years increase, so does the cost, right? We have a little bit more data and we can take it a step further. Okay? All right. Let's go to the back. Example 2. Oh, wait. Let's do one on your own, okay? Let's see if you're able to do it. You know, these we might have to save for the classroom, okay? Because you don't have a calculator. And so we can do that. If you do have a calculator, give this a try. Hit pause right now. Or if you're doing this in class, please hit pause. Okay, you got your answer? Ladies and gentlemen, the answer is B. Okay. If you didn't get that and you have your calculator, uh, please come back. Also, I encourage you that if you need to check out a calculator from me, you always can in order to take it home. There's also some apps. I believe there's an app called Wabbit, W-A-B-B-I-T, that allows you to download the graphing calculator. Okay. This one right here, cost and analyze the residual plot for the data comparing the years 2010 and the cost of repairs. Okay. So this is the years since we're going to pretend that this is since, and then since 2010, and then the actual cost of repairs. Okay. There we go. Graph and analyze that. Okay. So we're going to pull out our graph. Now, one of the things that I want to make sure that you know how to do, okay, is how to decide how much to make each line is worth, right? Because on this particular graph, we're looking at 1, 2. I mean, normally it's 2. I'm going to erase 2, but we have to kind of decide. And this graph, I believe, has 6, 7, 8, 9, and then 10. Okay? 1, 2. Somehow that doesn't feel right. These things are so light I can barely see them. Okay. Well, we're just going to pretend. All right. So this is X and this is Y. Well, it's no problem here because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We could just do very direct, right? 2, 4, 6, yeah. But on the y-axis, we have these really big numbers, and we have about 10 lines. So I like to usually take my biggest number, in this case, this one, and I'm going to divide it by 10. And I end up with 223. Okay, 223. Well, I'm going to raise it up to the easiest, nearest, easiest number to deal with. And I think 250 will work. So if each one of these is 250, this one's going to be worth 500, meaning that this one's going to be worth 1,000. And this one, 1,500. This one, 2,000. And this one right here, 2,500. Okay. So now we can like put our little points on there from our table. And I've got 2 1236, about right here, more or less. I've got 3 1560. Again, if you ever catch an error that I do, please bring it in. Probably get extra credit. 4 1423, a little bit lower, right? And 5 1740. So, yeah, about right here. And the last one, 6 2230. 6, 22, 30, about, okay? So now, we're looking for a line that will go through that, okay? So in order to come up with that line, I mean, you know, one way you could do it is you could just draw a line, you know, but there's lots of room for variance here, okay? So let's see, you know, I mean, I just kind of drew that line, but let's see what the calculator says and if it agrees with me or disagrees with me. We're going to go to our calculator. How do we put a table into our calculator? Stat. Very nice. So let's go ahead and do that. Clear. And we'll go to stat, enter. Now I'm going to delete all that stuff, okay? In order to delete this, you hit clear and down, and that will clear it out without erasing L2. Be careful, because if you erase all of L2, then none of this will work, and you'll have to do a reset. So again, you go over to the left, you hit clear and down, and it's gone. So let's put this in. We got 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. Okay, go to the right, and we have our cost. 1236, 1560, 1423, 1740, and 2230. Okay. So we got our 2 columns in. We go to stat, calc, 4, and we go all the way to enter. And we end up with this equation right here. Okay, so let's go ahead and let's look at our line of best fit. I mean, just looking at it, it's obviously positive or negative? Positive. Is it strong or weak? Strong, because the dots are close to it, right? And when we look at our equation, y equals 216.8x plus 770.6, okay, with an r, a correlation coefficient of 0.9. Okay, well, first of all, we predicted that it has a positive and strong correlation. Does our number from the calculator agree with that? Yeah, 0.9 is really close to 1, and it's positive. So yes, positive and strong correlation. Now let's see if our line was any good. They disagree. They think that the line that we should have come up with was a little bit more like, and that might be right, that it should have been a little bit higher, right? So something that starts off at 770. So maybe a little something more like this. Oh, hey, that's not really what I wanted. Okay, let me try again. So something more like this, where I start off here, you know, and absolutely, that has about half the, you know, it has probably more dots on the line, right? So, make sure any questions that you have, you write them down, okay? Let's go ahead and let's look and see if we have an example that you can do. Nope. So we're going to do this one together. Example 3. We have a table, and it shows the points earned by the top 10 bowlers in a tournament. How many points did the 15th ranked bowler earn? So now we got to use a graphing calculator to come up with that best fit line. And then we're going to extrapolate information to find that missing value, okay? We're going to predict what's going to happen when we have 15 here, okay? So let's put that in our calculator. It's a lot of stuff. Okay. Stat, enter. I'm going to go up here. I'm going to hit delete down. Ooh, I made that mistake, yes? I have L2 gone. I should have hit clear down. So if you do this, let's try the soft restart, 712, enter. And if this doesn't work, then you're going to have to do a hard restart, which all of this is in your foldable. So let me go back in, stat enter, and yay, I've got L1 and L2 back. Okay, the world is good. The only thing is that I don't have my correlation coefficient, but this example doesn't ask for that. Well, but I'm still going to do that. So how do I get that correlation coefficient? If you said mode, good job. We're going to go down, go to Stat Diagnostics, and I'm going to go to the right. Okay, I'm going to turn it on. Okay, see how it's now dark on there. I'm going to get out of there, second mode. Okay, I'm going to go to Stat, Edit. I'm going to put all my values in. Now, for linear, ooh, I made a mistake. I'm going to have to put 5 enter, and I'm going to put in 6 at the bottom, okay? So if you make a mistake like that, you just take that point and put it at the bottom, okay? So now I just got to make sure that I match up all the right L2s, all the y values with the correct x value. So with 1, I'm going to put in 210, okay? For this one, I'm going to put in 197, 164, and number 4, I'm going to put in 158. That's the only thing. When you get going fast, you're not looking, it's really easy to make a mistake. 151. Number 7, so we're going to skip one. That's 144. Okay, 8, 142. 9 was 134. And 10 is 132. And my last one, 6, because that was that one I messed up on, 147 enter. Okay. Now, if I want to look at how these look, I could just go to y equals and go up, select plot 1, go down, see how it's highlighted. You can go to graph. I don't see anything, so I'm going to zoom out. Is it showing me anything? Maybe I start off at zoom. Yeah, let me zoom out again. I'm seeing a little something, right? But it's all right, like on top of here. So this is one where unless I mess around with the graph, it's not really going to show me a very pretty picture. So let's get out of here. Let's create our equation, stat, calc, for, and enter. And we're going to enter until we see calculate. And there we are. Okay. So I've got r is equal to this, and the rest is my equation. Okay. So in order to come up with our equation, our best fit line, once I got done rounding it, I think to the nearest hundredth, I came up with y equals negative 7.87 plus, ooh, I forgot my x plus 201.2. Now, on this one, do we have any indications if it's positive or negative? If you said yes, you're correct, because look at this negative right up here in front of the slope. That tells us it's probably going to be negative. As one thing is increasing, as our rank increases, right? Look at what's happening to my numbers. In general, they tend to decrease, right? That's a negative correlation. If I look at my correlation factor, we had a negative 0.91. So it's negative, right? But is it strong or is it weak? And the answer is this is negative and strong. Okay? Meaning that if I did see all the dots, it'd be really close together. Okay? This would make a strong argument. Negative and strong correlation. Okay? Now we need to use that to predict the value. And you could do it two ways, okay? The first way you could say is y equals negative 7.87. Multiply it times what they want us to predict was 15, right? So the 15th ranked bowler. So what's going to be 15, x or y? If you said x, very good, okay? So we plug in 15 and we add 201.2. You could do that, or you could get really slick about it. And we go to our calculator Wait. Okay, you go to your calculator, and do you remember how to make it store it in Y1? When you're doing the stat calc 4, you go down until you get to store regression. And that's where you store vars to the right, 1, 1. And then you go to calculate. Now, the cool thing is not only that you can see it, I mean, because when you go to y equals, now you've got that equation in there. When you graph it, you'll see it. But what's even nicer is that you could go to your table, right? And I'm looking for my 15th ranking one. And because it's a pretty strong correlation, it's probably going to happen. And what is the score typically going to be for a 15th ranked bowler? 15 and their score of 83.1. Now we'll round out to the nearest number and we'll write that they will typically, okay, typically the 15th bowler will score 15th ranked bowler will score 83. Okay? It's probably what I would score if I was bowling. Okay? So that would answer how many points did the 15th ranked bowler earn? 83 points. Okay? Questions? Okay, write down any questions that you have, okay? I know this is a highly intensive calculator one, which makes it a lot of watching, and hopefully you have access to a calculator at home. Let's look at the final one, example 4. Unless there's an example. Yay, check your progress. All right, here we go. So if you have a calculator, go ahead, plug this in. Plug this in and hit pause, okay? Okay, so if you worked it out like me and you looked at it and you're like, oh no, none of those answers match mine. Well, then you did it correctly because there's actually a typo in this and we'll talk about it tomorrow. But in 2115, basically, none of these answers will work. The correct answer is that you could expect 9,057 passengers. Okay? That would have been the correct answer. Okay? All right. Let's go to the next one. Okay, example 4. Find a graph in the equation of a median fit line for the data on the bowling tournament in the table, then predict the score of the 12th ranked bowler. Okay. So I'm wondering if it's the same data. Looks like it. Wish I hadn't have changed my calculator. Oh, well, maybe it's still on there. Let's see. Let's go here. Let's clear all this good stuff out. And I go to Stat, Edit. And do I have the same? Yes, I did not erase it. Woohoo. Okay. So what that means, I've got the same data. And if you don't, you can go ahead and put it into your calculator. Okay. And then it says find and graph the equation for a median fit line for the data. Then predict the score of the 20th ranked bowler. Okay. So I'm going to go ahead. I'm going to choose Stat. Okay. Calc. And honestly, I think for the purposes of our exam and what we have as far as our expectations, we're going to stick with that linear regression line. So we're going to stick with Stat Calc 4. Okay, which is right here. Okay, I'm going to go ahead. I'm going to store it into my variable. So vars to the right, 1 and 1. Go down, hit calculate. I've got a new equation in there. And I'm going to show you how to do another technique on your calculator, okay? Because normally you would go to y equals. Yay, they plugged it in for you. Then you go to your table, second graph, and you can scroll down to 20, right? And you're going to end up with the score of, we're going to round it to the nearest number, so 52. Sorry, 44, okay? Which is not terrible, but what if they said they wanted like the 200th, right? That's a whole lot of scrolling. So let me go ahead and show you. X is independent or dependent? Independent. So what we do is we go to our table set. So I want you to hit second window. We're going to go down to our independent, and I want you to highlight ask. Okay? Now what that means is that you're going to go to your table and you type in any X value you want. So for example, for the 15th bowler, I type in 15 and I got 83, right? That was my answer for that one. Now, same thing, same exact data. I'm going to type in the 20th bowler. 20th, hit enter. And now I know that my score is going to be 44. Okay? So these are just some calculator techniques. When you get into class tomorrow, if you're doing this at home, you'll be able to practice this. Okay? And that's how you do that. Questions, comments, or concerns? Okay, I got to work on keeping these things a little shorter. Let's go back over here. Okay, of course we know 44 points for the 20th ranked, sorry, that's a cursive R, ranked bowler. Okay, there we go. Ladies and gentlemen, if you have any questions, please write it down. Okay, and I will see you tomorrow. Bye-bye.